Okay, now we're going to have a problem about another standard kind of distribution that's important. It's a continuous distribution called a chi-square distribution. Chi-square distributions have degrees of freedom that identify which one we're talking about, just like t distributions do. This one has 9 degrees of freedom. We're going to give our answers rounded to 5 decimal places. We want to find the probability that x is less than 19, the probability that x is greater than 10, probability that x is between 5 and 9, and then a couple of inverse probability problems. Probability that x is less than a is 0.01, and the probability that x is greater than b is 0.05. Find a and b. Comment on the skewness of chi-square distributions in general, and for chi-square distributions, put the mean, median, and mode in increasing order. Okay, the next screen is probably going to show you all of these answers, so please work all of these out before going on at this point and then come back and check. Please press pause now. Alright, here are all the answers and the screenshots. I'll actually kind of show you in action here on this one. We can do probabilities as chi-square CDFs, just like we do TCDFs and normal CDFs. They work very similar. And the FCDF for the next question is similar as well. So we can do second distribution. We go down and find the chi-square. Chi is actually a Greek letter that looks kind of like an X. So there it is. That's chi-square CDF. That's number 8. So we do chi-square CDF. And chi-square is one of the things that you want to know is that they start at 0 and go up from there. So probability that x is less than 19 really is from 0 to 19. So we want to start at lower is 0 and upper is 19, and the degrees of freedom are 9. Hit paste and enter, and that will give you the probability that we're looking for there. Probability that x is greater than 10, we could do that. Let me just pull that back up again, second enter. I could do this and go from 10, I'll show you 2 ways. 10 up to some number, I don't know how big though, let's say maybe 1,000, and then with 9 degrees of freedom. And that should actually work out pretty well, but we're trying to have to guess what we could put in there instead of infinity. Since we have a hard end of 0 on the other side, it might be better to do 1 minus the chi-square distribution, which is CDF, which is 8, and then go from 0 to 10, like that with 9 degrees of freedom, and do the difference there, and you saw we get the same answer either way. So either one of those is fine. The next one we can do chi-square CDF between 5 and 9 with 9 degrees of freedom. There's the probability we're looking for there, 0.397, etc. Now, the next one is an inverse chi-square. So you go here and you start looking, and unfortunately, you notice that there is no inverse chi-square. Bummer. Okay, so what we're going to have to do is do the, we don't have such a super shortcut going on. We can actually we're going to have to do it this way. So what you do is you graph the chi-square CDF. Now remember, the chi-square CDF starts at 0, so we're going to go from 0 up to our variable x, 9 degrees of freedom. We're going to paste that in as y1. Yeah, we're in y1. Good. We're going to graph the probability to the left, which is 0.01 as well. And we just have to calculate where those two cross, which is essentially what the calculator is doing when we do an inverse norm or an inverse t. For example, if you have some of the older TI-83 calculators, you don't have an inverse t, so what you're going to do is have to do it this way. You have to graph the t CDF, horizontal line, and calc intersect. That's what pretty much all of you are going to have to do on the chi-square CDF, unless you've got a TI-89 or a TI-Inspire calculator, which has an inverse chi-square built in. Now we need to get an appropriate window so we can see this. Chi-squares start at 0, so we can go from 0. Let's just go 3 times the standard, the degrees of freedom. So maybe go out there to like 27, and then it's a inverse thing. So I'm going to do negative. I'm going to go negative 0.4 to 1.1. Let's say this time. And what we should see is it starts at 0 and goes up to 1. So it's going to be real close to the x-axis for a little while, then it comes up pretty quickly, and now it's going to level out, and it's going to approach 1 on the right. Actually, it's an asymptote on the right, but an actual hard number at 0, 0 on the left, specific number. Okay, it takes a second for that to graph, and then it graphed a horizontal line. Now the horizontal line you can't really see because it's so low. It's at 0.01. So on this scale I can't really see it down here, but it's there. So I want to calculate the intersection of those two graphs. So first of all, I'm on that graph. That's good. And secondly, I'm on this horizontal line, which you can't tell apart from the x-axis on this scale. So, but it's the right one. Y equals 2 equals 0.01. Hit enter. And then that's my two graphs, and then I want to go over here close to where they cross, somewhere in this vicinity, and hit enter and see what happens now. Yep, there's your x value and your y, and that x value is what we're looking for. That's the value A, 2.08, etc. Now when you're given a probability to the right, it's the same thing, but instead of putting in the 0.05 for y2, you put in 1 minus 0.05, or just 0.95 in this case there. And we want to calculate an intersection again. We're going to have to wait for it to graph again. But we're going to find the intersection here. This time, the horizontal line will be up close to, well, it'll be at y equals 0.95, up close to the top. And hopefully we've gone out far enough to the right that we can see the point of intersection. Yeah, you can kind of see it's right in here somewhere. So I've already said calc intersect, first curve, enter, second, enter, and then I'm going to use my arrows keys to get somewhere in the ballpark of where they're crossing and hit enter. And this is the x value that we're looking for. So chi-square distributions are always skewed to the right, and they're always in the order mode, less than median, less than the mean. Okay, so there's some things with some chi-square distributions. In our next unit, we'll see how we'll use the normal chi-square, t, and f distributions to do some inferential statistics, along with maybe a binomial and hypergeometric as well.